This instructional video is on calculating and interpreting slope. The formula for the slope between the 2 points A and B can be found by using the x and y coordinates of the 2 points. Call the ordered pair for point A, x1, y1, and the ordered pair for point B, x2, y2. So slope equals rise over run, and it also equals y2 minus y1, excuse me, x2 minus x1. And another thing you're going to see when you see slope, you're going to see equals m. Okay. 1. Plot the given point on the coordinate plane. Oh, I forgot to read this line. The slope of a line can always be represented as a fraction. For example, if the slope is 5, we can write 5 as a fraction because 5 means rise is up 5 and run is right 1. So number 1, plot the given point on the coordinate plane and then use the slope to find a second point on the line. All right, so what we're going to do, first of all, since these numbers are below 10, we're going to make sure this is 0. And this is 1, 2, 3, 4, 5, 6, 7, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. This one, I'm going to do minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. And this is 1, 2, 3, 4, 5, 6. Okay, so the first point we have to do is 2 dash 0. So we go over 2 and we stop at 0. Okay, so this is 2 dash 0. Now when we do the slope, the rise over run, so we go up 3. 1, 2, 3. And we go over 2. All right, so that is rise over run, 3 over 2. So we went up 1, 2, 3, and we went over 1, 2. And this coordinate point is 4 dash 3. Okay, and then we can draw a line. Okay, so the second point is 4 dash 3. Okay, then the next one, I'm going to label them again. 1, 2, 3, 4, 5, 6, 7, and it looks like it goes up to 8. So I'm going to make sure we label all the way to 8. 1, 2, 3, 4, 5, 6, 7. I'm going to put the minus signs. Minus 8. So this is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, and this is 1, 2, 3, 4, 5, 6, 7, 8. And notice I'm putting them on the line. Okay, so we are going to do negative 8. So we go over to the right, negative 8, and we go up 4. So this is negative 8, 4. Now the slope is negative 1. So we're going to go down 1, and it's over 4. 1, 2, 3, 4. So we have this number is negative 4, 3. So I'm just going to draw a line so you can see they're connected. Okay, there we go. All right, so the second point would be negative 4, 3. Okay, so that page is done, and we're going to move on to the second page. So we're going to do this again. So we have 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. This is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. This is 1, 2, 3, 4, 5, 6, 7, 8. And notice I put them right on the line because otherwise you're going to get all mixed up. So the first slope is negative 3. So we go to the left because we go x, y. Negative 3, and then we go down to negative 5. So this is -3, -5. All right, now the slope is 2. Remember, you can always make it into a fraction, 2 over 1. So remember, this is a change of y over change over x. So we're going to go here. We're going to go up 2, rise up 2, over 1. Okay? So this one is -2, -3. And then we're going to draw a line to connect the dots. Okay? And this one is -2, -3. I want to make sure I put the -3 there. Okay, thanks everybody. All right, so then the next one, again, we have to label so we know what our scale is, and we are still using smaller numbers, so we don't have to adapt, thank goodness. Okay, so the first point is -2, so we go -2, and we go down, we go up, excuse me, -2, and we go up 7, because that's positive. So this is -2, 7. Then we have to use the slope, -3, and remember, -3 is over 1. So we're going to go down, because it's negative, 1, 2, 3, over 1. So this point would be -1, 4. So -1, 4. So I'm going to put the number here, and we are going to connect the lines. Okay? So we went down 3 because it's negative, and we went over 1 because it's positive. All right? Now, using the slope formula, we can do y2 minus y1 over x2 minus x1 equals. So now I always label my coordinate x1, y1, x2, y2, only because it makes everything easier for me and I think it flows better. So y2 is 9, y1 is 5, x2 is 2, x1 is 1. So 9 minus 5 is 4, 2 minus 1 is 1. All right? So again, x1, y1, x2, y2. So we are going to do y2 minus y1, x2 minus x1 equals y2. 1 minus y1 is 4, and then x2 is 1 minus 2. So 1 minus 4 is -3, and 1 minus 2 is -1. But remember, negative divided by negative becomes positive, so this becomes 3 over 1. Okay? Now down here, we have x1, y1, x2, y2. So we're going to write the formula again, because again, it keeps you where you need to be. So we have y2 is 8 minus 4, then x2 minus 2 minus 0. So 8 minus 4 is 2, and -2 minus 0 is -2. So if we divide both numerator and denominator by 2, we can get 2 over -1. And this is simplified. Let me put the I in there. Simplified. And then the last one here, x1, y1, x2, y2. So y2 minus y1 is divided by x2 minus x1. So we're going to do y2 is 4 minus -8. Then we're going to do 6 minus 8. Now when you have two negatives together, it becomes a positive. So 4 plus 8 is 12. And when we have 6 minus 8, it's -2. And when you divide 12 by 2, or when you divide 12 by 2, you get 6. And when you get 2 divided by 2, you get 1. And so you get 6 over -1. Okay, and let's see. Let's get these last couple done. So again, we're going to label them X1, Y1. And I'm going to pause the video for a minute because I want you to try these on your own, and then we're going to go over them in a second. Okay, now take a quick minute to check your answers. If you need to, just pause it and look over the answers, okay? The next step we're going to do is sometimes it is useful to express slope as a unit rate. A unit rate has a denominator of 1. An example of a unit rate is $8 per hour, and it's written $8 divided by 1 hour. That is the same as $16 per hour, because if you divide both sides by 2, you get 8 over 1. In a distance time function, the slope may be 3 meters per second, which is also 3 over 2 meters per second. As a decimal, it is 1.5 meters per second, or 1.5 meters per second. So if you divided 3 by 2 and 2 by 2, you'd get 1.5 and 1. Okay? Now, Mr. Peel started 7 meters away from the motion detector, and 2 seconds later he was 3 meters away from the motion detector. The graph below displays Mr. Peel's motion. Find the average rate of change in slope per second. So if we look at this, we know that it goes, I'm going to take these 2 points, and we go up, we rise 2 meters, because we're going up on the y-axis, and we go negative 1 in seconds. So we have 2 meters per negative second. So he's dropping, okay? And that's why it's a negative slope. All right, last page. We have Sarah started with $50 in her piggy bank. Every week she deposited the same amount of money in the bank. After 7 weeks, she had $67.50. Find the average rate of change or slope in dollars per week. So we know the total is this. And she had 7 weeks. And we don't know how much she's depositing, so that's the variable, plus 50. So we're going to solve the equation. 6750 equals 7x plus 50. So we're going to subtract 50, subtract 50. This becomes 750 equals 7x. So we're going to divide both sides by 7, and we get 250 equals x. So it is $250 per 1 week. Okay? Now, we are going to do, at 4 a.m., the temperature was 38 degrees Fahrenheit. The temperature had risen to 60 degrees Fahrenheit. Find the average rate of change in degrees per hour. So we have the final temp is 60. We have the 7 hours that lapsed. And we have the starting temp. Okay, so we're going to 60 equals 7h plus 38 minus 38 from both sides. These cross out. This becomes 22 equals 7h. We divide both sides by 7, and we have 3.14 equals per hour. So it was 314 degrees per hour. Okay? So how I figured out the hours lapsed was 4, 5, 6, 7, 8, 9, 10, 11. So that's 1. This is 2, 3, 4, 5, 6, 7. Okay? Thanks, everybody, and I hope you learned. And please remember, you can go back, you can pause it, and you can make the video bigger. Thank you.